All right, we're back today. It's the next day. So we got this thing running last night, and now today we need to get everything else that we want set up on the car ready so we can get to tuning it. Because while it runs, it is not currently in a state where it can be tuned. So what I've done is I went ahead and just got the old handy whiteboard and just kind of made a list here. So we've already installed the Haltech, but there's a few things that we need to add to it before it is in a state where I feel like it's ready to race. These last two are less important than the first two, but yeah. So people would say wideband is super important, but the tune is the tune is the tune, and we don't necessarily need a wideband while we're out on the track. It'd be nice, but we'll see. Trim switch, again, this is to allow us to on the fly change power, not required, but fuel pressure sensor is pretty critical. Flex fuel sensor is also pretty critical in my opinion. Other few things we need to do to the car: we need to drain the fuel. It's got 3-year-old gas in it. We need to install new injectors. We're modernizing, plus these thousands just aren't going to cut it. Power steering has an issue. Basically, the system was taken apart and put back together and never bled. Fix the wing. There's that little gurney flap on the wing. We need to tune the car and clean out the car. As I was just talking, my injectors have been delivered. Let's see if my thumbnail's sharp enough for these. Come on now. Quality assurance. Ooh, there they are. All right, these are FIC 1650s. These are going to require wiring in because they use a different connector than what's on the car. The car has stock injector clips, probably, yeah, because these Denzos used the stock injector clips. So we'll have to wire those in. So let's go ahead and add that to the list. And then I was just informed I have new wheels and tires coming literally since about 10 seconds ago. So we need to install injectors and wire connectors. Now, the reason why we went with 1650s and not something bigger is, let's come over to the dyno here. This is the graph from the car previously. This was actually on 1000cc injectors, 483. We were pushing, and I had the fuel pressure, the base pressure turned way up to try to get this, and we were running pretty lean, 1220s, 1230, 1240 in various spots, and it was only at 23 pounds. So not a ton of boost, but making really good head flow and 483 horse. So we're actually not trying to push the power much further than that, just because it's not really necessary. And this car, the motor is pretty old school. It's just a hybrid 2.5, like I said in yesterday's video. The cylinder heads have not been chamber matched like we do, so it's kind of a high comp, weird squish 2.5 liter engine. Not the most ideal. And on top of that, if you come in here, you might have seen this is a 5-speed. It's a Type RA, but it's still a 5-speed. So we can't really launch the car super hard, and we have to be a little careful with the motor because it's an open deck design. It's nothing closed deck, no O-rings, nothing special. This engine has been well used and only abused, and it has a lot of race miles and hours on it. So it's been track date, it's been hill climbed, it's been autocrossed, and that's what it is. I mean, that's what this car is. So we have to be a little bit careful. All right, let's come back over here to what we've got. I'm gonna wire in one of these guys here. This is a Deutsch 8-pin connector, and so that's what I have drawn here. Now, when you look at the Haltech little book that it comes with, they give you an auxiliary connector that has a bunch of outputs, but it doesn't have a lot. It actually only has one spare AVI and one spare SPI. So one analog voltage input and one, basically, this is going to be flex fuel, and that's going to be fuel pressure. I'd like more, so what I do is I'm going to come into the book here and just look at what other things aren't being used. And I noticed we had AC request, which we don't have air conditioning. Power steering oil pressure switch, we'll probably leave that hooked up for now. We have all the oil control, solenoid valves, tumble generator valve open. This harness doesn't use a tumble generator valve signal. I'm not really sure how they were controlling them with this, but anyway, we also have the AVCS cam positions that this car doesn't have, and then the mass airflow signal. So what I'm actually probably going to do is use that mass airflow signal. So we'll do AVI 5, SPI 1, AVI 1, AVI 5, and I'll see if I can find 2 others just by going through the book, and that way we can have all of our inputs on there. And then I'm going to bring a 12 volt, bring a 5 volt, and bring a ground out into the engine bay. Maybe I can just do these 6. That might be okay, because then anything that's inside the car will run on. Let's see if I have a 6-pin connector. Oh, I do, for sure. So yeah, I have a 6-pin as well. We might just do this one, because ultimately this is going to be flex fuel, this is going to be fuel pressure, and this will probably be like oil pressure or temperature in the future. So let's just do it that way. Let's do a 6-pin. And then if we want to add more inputs to some of these other things that we don't need, we can do it inside the car, which is where it's more likely going to happen. Wideband O2, I was just informed, is being next day aired. It'll be here tomorrow. That's going to be CAN bus, so we don't have to worry about wiring for it. Trim switch, I need to ask him if he wants to do. I like trim switches, but we'll see. Beyond that, we're going to get to all that. So first thing we got to do is wire up the 6-pin connector and get it installed. The next thing we have to do is decide where we're coming through the firewall. I am thinking down underneath the brake booster is probably my best option. You're not going to be able to see it, but there's a grommet down there. That's going to come under, and then we'll just come across to the ECU. That'll be the tidiest. Over here is obviously the easiest grommet through, down by the turbo. The problem is it's next to the turbo. If you get a fire or something going on, all of your wiring is going to be smoked. And it's just cluttered over here. Like, everything's super tight. There's already a bunch of connectors. It's just, there's all this space, all this room for activities here. So this is the side we're going to go on. There's a few different ways to do this. Unfortunately, I don't have a lot of wire colors right now. I just have black and red. So I'm going to do all my signals and grounds in black, and then just do my powers in red. Both 5 volt and 12 volt will be red. So documentation is important, and I'll probably just write myself this little schematic. I'm going to populate DPO3 and do the 8-pin. We'll leave a spare. I'm going to pull the spare through, but we're not going to connect it to anything in case we want to connect it to something later. So this will be a spare DPO, so an output for another fan or a relay or something, and then our 3 inputs coming through, and that's what we're going to do. So I'm going to go ahead and build that harness connector and get it pulled. I'm not going to show that process because that's just time consuming. And yeah, make sure you use the correct crimping tools. Like if you're using these little Deutsch pins, you have to have the correct style of crimper for them. If you're using W terminals, like the Tyco connector that goes in here, I believe, yeah, they're here in this box. If you're using these Tyco connectors, you have to, again, use the correct crimping tool. If you use the wrong crimping tool, you're gonna have nothing but problems down the road. So use the correct crimping tool and the correct wire gauge. This is 18, I believe. These are made for 18 or 20 gauge. Even 18, if it has a lot of shielding, might be difficult. This might be 20, let's see. Oh, it's 20, yeah. So, yeah, use good wire, and smaller wire gauge will be okay. We're not pulling a lot of current through this. It's not going to be high current, so we should be fine. I pulled the grommet out from underneath the brake booster, and I cut a little hole in it. And I have the first like 3 feet of this loomed, and the rest is not loomed, but the wires are marked. So I'm going to go ahead and shove them through, and this is what's going to hang out in the engine bay here. And part of this is going to be loomed as it goes underneath the firewall, but the rest is unloomed. And there's a lot of spare here. We're not going to use all of it, so I'm going to get that installed. But just wanted to kind of show you, this is going to be our engine bay auxiliary plug that everybody's going to wire into. And I didn't wire relief it or do any of that fancy stuff. We're not doing that with this car. Okay, we've got our wires ran over now. I actually found tucked up in there an old Innovate wideband. So we're going to probably pull that out because we're going to be switching to the Haltech CAN wideband for reasons, and I'll go into that when we plug it in. Anyway, I have my wires, they're all marked. Now I need to connect them all to this auxiliary connector, which is this little guy right there. This guy here. I absolutely hate using Tyco pins. These are my least favorite pins in the entire world. If this were my car, instead of pinning into this connector here, I would just go and put new pins straight into the ECU mains. It's so much simpler, just boom, ECU main, call it a day. But since we're using this plug and play adapter and we don't want to hack it up too much for whatever reason, I'm going to go ahead and pin them into this Tyco connector. These are the world's smallest pins, and they are one time. You get one shot at crimping them right. Once you shove them into the hole, the pin connection gets super tight. They're just a pain in the ass. I hate them. Deutsch pins and then the pins that they use in these connectors are so much easier to work with. But for the sake of this exercise, we're going to go ahead and use these. I went ahead and marked my pin 1, 2, 3, 4, 5, 6, 7, 8, and I need to mark them on this diagram so that it's a little bit easier to figure out where we're going. All right, it was painful, but they're in. So we're into our Tyco connector, into our adapter box, into our ECU, and we're going to build a little plate to mount all this. So I need to go write that on the list because it's not on the list currently. Yeah, this will all get mounted under this nice little kick plate we've got as well, so it'll all be protected. Yeah, now we need to go wire sensors to the other side of this, but at least now we know that it's in here. In fact, we'll go test the other side and make sure that the powers and grounds exist where they're supposed to first, and then we'll wire the sensors. You've got this little guy, you got your wires, you got your split loom. You want to make sure that the end that's opening is what's going to scoop in to the wire there. So we're going to go ahead and get it in there. And then the split loom actually reverses as it comes over, see? So what was under is now going to be on top. Oh, caught a little bit of an edge there. I was going too fast for the camera. Anyway. You can do that for as long of a run as you need to. You could do a 30-foot run that way and it would take you seconds. So get one of these. It's a OTC 4462-4. Went to install the sensor on the fuel pressure regulator, and it's going to bottom out on this big nut before we can get it tight. Luckily, they make a little adapter that I'm going to put on this side. It's going to make this work really, really well and be pretty simple to do. Here's the fitting from Red Horse. That's the package, a 9192-06-2. And it's a -6 with an 8th NPT. So I'm going to go ahead and get the sensor in here and then just install it right there like that. Got that in. Aesthetically, you can't even see it very well. It's down there. We'll go ahead and just run our cord or our harness that we made and plug it in, and it's basically effectively invisible. Nice, tucked away. You're not even going to see it now. So that works, and we still have our mechanical gauge to double check against, and this is still set up for flex fuel in the future. We're going to go ahead and do that next. Got the flex fuel mounted, got the fuel filter remounted. Now I do need a little bit more hose. This is fuel injection hose to run from here to there and then there to there. Just had not quite enough, and the hose that came off here was pretty janky, so we're going to replace it with some good hose and get that done. So the next thing I'm going to do is do these injectors. Not going to show that process either because it's just an injector swap. There's plenty of videos how to do that. I just want to take one quick second to show you a little trick of the trade. So here is our injector match. You can see 52 is a 1547, 67 is a 1566, a 1566 on number 84, and JP05 is a 1542. So I've got two 1556s and two 1542s. So what I want to do is put the 1556s in cylinder 1 and cylinder 4 because those are the two cylinders with the dogleg. Now you could trim everything in the ECU by entering all this information individually, and we'll talk about that when we get there, but for now we're just going to do cylinder 1, cylinder 4. So I want a J048, that's an 05, let's find it. 60, this will be fine. We'll do the 67 in number 4, and we'll do this one in number 2. This set of injectors came with the plug-and-play adapters, which makes life nice. If I had more time, I would prefer to hardwire these, but these will work for right now. All right, while we wait for that fuel line to come, we've installed the pressure sensor, installed the flex fuel sensor. We have wired this guy. We've installed the injectors and connectors. I should just write wire aux. Just write it so I can cross it out. All right, we still need to, this is coming tomorrow. All right, let's drain the fuel, and then we're going to go ahead and calibrate what we've done so far, get the ECU knowing what injectors are in it and these new sensors. But we can drain the fuel while we're waiting for this hose, because the hose is just the return line hose. So we're actually just going to hook the return up and kick the pump on and drain the fuel. One of the quite odd things that Haltech doesn't do is give you test mode outputs on the Elite. The PD16 and the Nexus do, but the Elite doesn't. And I want to kick the fuel pump on so that it will drain my tank here. So what we're going to do is go ahead and go to the fuel pump and see, we can set up a primary pump here. We can set, I believe that this is to run the factory at low RPM. It's going to always run. So primary output, we want to set up an override switch effectively. So what we're going to do is see what we could assign to be an override switch. So these are a bunch of inputs that are currently available, but we want to see if we can set up one that's already been used. So this is the AC request. And when I press that button, boo. It must already be disconnected. Well, that's not going to work. Don't know. Let's do conditional. So if we set it conditional and conditions only, selected channel name, RPM is equal to 0. Let's do the same for the other one. Conditional. Condition RPM is equal to 0. Now, in theory, pump should just stay on. See, we've set conditional outputs. So while there is no test mode connector, like I keep telling people with Haltech, if you just think about it, you can do basically anything. You just have to think of a way to do it. And it may not be clear what that way is, but if I hit clear on these and then restart the ECU, or if I turn off the key it's going to shut off the pumps. But in the meantime, pump is going to run, and we have fuel coming out of the tank, and that's some nasty looking fuel. So we're going to sit here and let this thing drain for a little while. While it's draining, something I want to notate for you, we do have fuel pressure, 40 pounds base. So let's check for leaks on those injectors we just installed. Looks good on that side, and looking dry on that side. So I don't see any leaks on any of the fittings that we put in or installed, and we're draining fuel. Now while I'm draining the fuel, might as well be doing other things. So we can come in here and we can set up our sensors. What did we turn on here? We added flex fuel temperature, and we added fuel pressure. Where's fuel pressure? All right, so we'll come in here. We're going to load from file on the fuel pressure sensor. This is going to be just a generic 150 psi sensor. Right there. They're calling them Haltech TIs. It is a Fuel Tech sensor, same scaling, 0.5 volt, 4.5 volt, 0 to 150. Wiring. What wire was that on? Let's check our little book that we wrote in. Fuel pressure is AVI 1. Assign AVI 1, and it's currently got 1.74 volts. What's that give us on our pressure? Oh, we have to restart the ECU before it'll read. All right, now same thing with flex fuel. We need to assign, and that was SPI 1. And let's set that one up. All right. And then again, we need to check our fuel composition. Yeah, see, that's not correct. Load from file, flex fuel. Where is it? Oh, fuel composition, digital Haltech. Boom. And then fuel temperature, load from file. And we'll do temperature, digital fuel comp Haltech. There we go. All right, now we are going to restart our ECU, and let's see if we have fuel pressure now. Pressure's reading 46.5, so the pressure reads a little higher than what that mechanical gauge reads, and that's not uncommon. Check where we're at on the drain here. Still draining good. I'm going to go ahead and get another can and get it draining, but everything is working. Flex fuel is not going to read because we aren't currently running through that. Right now, yeah, it's mad about it. Fuel composition, yeah, flex fuel sensor 0% because it's not seeing anything because we don't have anything going to it. So anyway, I'm going to drain the fuel and get new fuel in here, and then hopefully that fuel line will have shown up and we can start the car. Well, since I have trust issues and I don't believe the tank is fully drained, we're gonna go ahead and see if we can't crawl under here and get the tank the rest of the way drained. So it's on. So yeah, because it's a WRX saddle tank, luckily this is the one that has the plugs on both sides. Some years do, some years don't, but this will let us get 100% of the fuel out. Got all the old GT spec arms, hard race arm, or GT spec braces, hard race arms, some cool suspension bits, bushings and everything. Yeah, gonna get it 100% drained, get new fuel in it, and fire it up. So when people tell me they're just going to drain their fuel and do a E85 and a pump gas map, how are you draining your fuel? Are you draining it this way? because if you're just draining it out the front of the car through the fuel pumps, this was all left in. That's at least 2, maybe 3 gallons, maybe more. I don't know how many gallons this pan holds, but yeah, it's enough to definitely mess up your fuel content. And if you don't have a flex fuel sensor, even if you can't run flex fuel on your car, at least having a gauge that's going to tell you your actual content so you can load the right map is super important. Just switching to E85 or to pump gas, you're never going to get there. This is what I pumped out. This is what came out the drain. And you can even see how much more nasty that side was than what pumped out. This is probably actually mostly water because it was on top. Fun stuff. Anyway, this is what would have still been in your tank if you had just pumped. You would have still had almost an equal amount of fuel as what you pumped out through the fuel pump. The Venturi only works, that gets the fuel from the one side or the other. It only works if the return flow is hooked up. So if you take the return off to pump the fuel out, it's not going to work. And if you take the feed off, obviously you have no return either. So yeah, fun. All that nastiness was in the tank. Now it's all out. All right, so let's get these injectors scaled in. Now we have a card that has a bunch of information, and we're going to use as much of the information off this card as possible and then fill in some blanks with some standard information. One important thing I like to mention about FIC injectors, they rate them at 1650, but as you can see, 1550 would be the average. 1556 to be exact. I don't know why they're rated higher than they are, and it's kind of irritating to me. But anyway, so we had just a one-dimensional flow rate. We're going to fix that here, and we're going to give it the axes that they give us. So we've got pressure here across the top and flows at different pressures. So 43.5, 58, 72.5, and 87. So this is going to be differential pressure, injector differential pressure, and this is why we put a fuel pressure sensor in the car, so we can correctly measure this. Oops, we don't need 0. So 43.5, 58, 72.5, and 87. Wish we had some lower numbers. We might go and find some lower numbers later. That's all we need for that, because that's all of the data we have. If we had different fuel temperature data and stuff, and the fuel temperature data is actually going to be populated as well, but a little bit different way. So we are 1556, and then we are 1796. Oops. And then we have 2008, and then we have 2200. So as you can see, these injectors at higher pressures get really big really fast, and that's kind of nice. The next thing we're going to do is go ahead and do the same thing for the dead time. Now we actually have real numbers, but we're going to be 8, 10, 12, 14, 16, and actually I don't think we have 8. Let me check. 8, 10, 12, 14, 16. Yeah, we do. All right, and then injector differential pressure, same as before. Now what we have is something that looks very similar to the data that they are going to give us on the sheet. I guess I flipped my axes, so it's going to look a little different, but it's the same thing. I'm going to go ahead and populate this and not make you watch me type everything in, but we'll get it and go to the next thing. Okay, populated it. They didn't give us data for these 2 points here, so I just went ahead and entered 8 milliseconds. The rest of it's all data. One of the weird things, this right here, from 1 at 87 to 1.02 at 72. I don't believe that, but we probably won't be up there. Yeah, I'm not really sure why their machine spit that out. Firing angle, we're just gonna set this to 360. I don't really want to do, I don't know what my cam is. If I knew what the cam that was in here was, we could calculate the firing angle fairly accurately, but we'll just do 360 for now. So that we've now characterized our injectors. Now we do need to go in and tell it that it is flex fuel, not this ethanol petrol blend that it was. And we want to do auto VE air temp. So let's go and check our air temp corrections, make sure it's not, in fact I'm just going to make that half of what it was. So we're still going to let it, we'll just zero this for now since we're doing auto air temp correction. If we find that we need to add some additional air temp correction, we can. Coolant temp correction, this is for like cold start. We'll leave that alone for now. We may have to add and subtract fuel. You want to be careful tuning this before you have a good VE map. Once you have a good VE map and you know up here that your VE is solid, then when you start the car you can see if you need to add and subtract fuel. I fixed flex fuel. For some reason it was set to a reluctor. It needs to be a Hall effect falling edge. Now we're reading correctly. 97% ethanol, spicy stuff. 77 degrees fuel temp, that checks out. Coolant temp 74. Air temp probably pretty close to that. Let's see, sensors. 78. So we're fairly close. I haven't ran the car. Close enough. I'm okay with it. All right. Now I wanted to talk about fuel system itself. The primary fuel density. This is one that we're going to go ahead and set up and get dialed in. Now this is a bare. So what I'm going to do is just come into another car that I've done it on. Primary fuel density here. And I'm just going to go ahead and import this into this other map. Pretty basic. There's a couple ways you can do this. You can actually do a compare import, or you can just copy pasta. So we're just going to copy pasta. Flex fuel sensor, 0 to 100. And then this is going to be fuel temperature. And I'm just going to go ahead and copy pasta my fuel temperature here. Voila. And then what these numbers are and represent is the actual density of your fuel, whether it's gasoline or ethanol. And this is typical pump gasoline. And there is variances because if you were running race gas or something else, those numbers might be different. But these are the kilograms per cubic meter of how much it actually weighs. How many kilograms of fuel per cubic meter of fuel. Let's make sure the units are the same. Yeah. So that's it. That's my fuel density. And this is how, when the fuel temperature changes, which we can monitor now, it's going to correctly know what the fuel density is, which it's then going to pass through into the fuel injector characterization, which we've characterized down here in stage 1, the flow rate and the latency time. All of that together builds you a modeled fuel system, which lets, as long as you have all that information, pressure, temperature, and you know what the weight of your fuel is, you can really accurately calculate your fuel injection volume. So I'm going to turn off the air conditioner control, and people talk a lot about bugs in Haltech, and I find there's not as many as people think, but one of the things I have ran into is sometimes when you just disable a function, if you don't, see, there it went, if you don't clear the functions first off the wiring, so I'm going to clear, and then I'm going to disable. All right, now we've got some errors, and that's because we are using there are different functions that are using the air conditioner. So we need to go in and find, so idle control is using the air conditioner. Anything that's now basically faulted because we have turned off the air conditioning, we need to go in and disable the axis that was set for AC. So now we have the outputs are now been deallocated, and we can go in and disable all the axes that we're using air conditioning. And there you go. So there's idle control, long-term trim. We're going to zero that because we changed everything. Anyway, so now we've disabled the AC and reallocated those wires to be anything that we want now. Okay, I'm gonna go ahead and set the laptop next to me and see if she'll fire off. Now we have a lot of ethanol in here now, not the low content we had before. And I think I've got a jump box on it, but it still cranks kind of slow, so here we go. That fired off pretty dang good. This is what I was talking about. As long as you characterize everything really well, you'll find that the cars just kind of work. So now we want to check our closed loop, currently idling at 56%, so we can fix that. And these are things that you're just going to have to kind of like mess with as you go along, and it'll change once we get everything, you know, all the fuel system dialed in, the VE table dialed in, everything. I think it's kind of rich right now because I added a lot of fuel. I still don't have a wideband in the car. That'll be here tomorrow. So we're just going to tune it using the dyno's wideband sensor. Yeah, I can smell it. It's pretty dang rich. But we also have a lot of fuel coming in this coolant temp correction here, like 17% or so. I think that's probably pretty aggressive. I just halved that table for now. Yeah, so fires right up. New injectors, new fuel, fresh fuel, and our sensors seem to be working. Flex fuel 97%, fuel temps working, injector pressure differential 45 psi. Like I said, I had to turn the pressure up previously. I'm going to go ahead and turn that back down just a little bit. I want it around 40. No, we can leave it at 45. Let's see what the throttle feels like here. Throttle feels pretty responsive. We're idling pretty good. We're making decent vacuum now. So it's a lot happier with fresh fuel in these injectors. And that's what happens when you characterize. Like this, I had never started the car, and you can see the coolant temp still only 117. I'd never started the car on these parts, and we just went in and put as much data as we had as they gave us, and then we used a little bit of additional data for the fuel specific density, and now the car runs, and it runs well, and that's couldn't ask for more. So I'm gonna get this strapped down and start doing some tuning, and that'll probably be a different video. So for today, for this video, that's what I have for you. Use your data, get it into the computer. If you have good data, good information, and you can get all that characterized, you'll find that the cars just kind of work. From there, tuning the VE is very simple. Tuning the boost control, very simple. Tuning the ignition timing, a little bit trickier if you don't have a dyno, but if you have a dyno, it's also not that hard. Yeah, this is just another example. I have spent most of the day on this car now, but there was a lot of mechanical stuff. My list over there, power steering hasn't been bled. You can hear it. So I still need to fix the power steering and fix the wing and swap the wheels and tires, clean the car. It's got a bunch of spare parts and things in it, and then just do a basic inspection of the brakes and some other stuff. But all the wiring is done. The engine management is installed. I need to mount it. I'm going to go add the mounting it to the list, but it's looking pretty good for today. So thanks for watching. Stay tuned, and we'll get more videos of this car up until it hits the track here in a couple of days. Have a good one. Eat tacos!